principle, the super heavy booster can be reflown within an hour of.
My dog is watching Elon Musk. Yeah. Yeah. Okay. Are you just listening, Baba?
Scored by the tower arms, placed back in the.
Just listening, Baba?
Reflow found in about.
Do you want me to take off your collar now, Baba? Since we're done training? Since we're done training, Baba? There we go. Good boy. Done training. Good job.
It's in the limit of rapid reuse.
Old Spice cashmere and vanilla.
Oops.
24/7 cologne quality scent.
Stay.
Georgia plans weddings with the precision of a watchman. Surprisings weren't their specialty. Of any flooding. The Ohio Watch Georgia read over plan in minutes. Georgia runs the show. Co-pilot.
Yes.
Keep it on track.
It's okay. Just wait. It's okay. Good. How are you, baby?
You know the name, you know the capability, and you know the quality. The four
Archie's watching TV. Yes.
Unmatched Ford F-150.
Wait, watching ad.
Luxurious truck.
You're watching an ad. Nope. Stay. Back up.
And then the next thing we need to do is catch the ship too. So we haven't done this yet, but we will. So that's what we hope to demonstrate later this year, maybe as soon as 2 or 3 months from now. And then the ship would be placed on top of the booster, and then again refilled with propellant and flown again. With the ship, it takes a bit longer because it's got to orbit Earth a few times until the ground track comes back over the launch pad. But the ship is also intended to be reflown multiple times per day. This is the new Raptor 3, which is an awesome engine. Again, to the Raptor team for this. This is very exciting. So Raptor 3 is designed to require no basic heat shield, saving a lot of mass on the bottom and actually improving reliability. So that if
Is that where you like to sit down, Archie? Is that your favorite spot, Baba? Is it okay while you sit there, I watch? Is that okay? Thank you.
Contained in a box is a very scary thing indeed. So this is a Raptor 3. It'll take it probably a few kicks at the can, but it is a massive increase in payload capability, in engine efficiency, and in reliability. So this is really a revolutionary engine. Raptor 3 is really, I'd say, kind of alien technology rocket engine. I mean, even industry experts, when we showed a picture of the Raptor 3, said that engine is not complete. So then we said, well, here's the engine not complete, firing at a level of efficiency that has never been achieved before. So. I mean, that is one clean engine.
Archie, you ready for crazy world? Yes, baby.
So to make an engine like that, we had to
be Mars.
Secondary fluid circuits and electronics in the structure of the engine itself.
Easy technologies.
Protected. It is a marvel of engineering, frankly. And one of the other technologies that's key for Mars is doing orbital propellant transfer. So you can think of this like similar to aerial refueling for airplanes, but in this case, it's orbital refilling of rockets. which has never been done before. But it is, technically feasible. I always feel like these things are a little NSFW, sort of. Listen, you got to transfer fluid somehow. This has got to be done. So the the two starships would get together, and one starship would transfer fuel and oxygen. And actually, most of the mass is oxygen. It's almost 80% oxygen that gets transferred, a little over 20% fuel. And so once you send a starship to orbit with that's full of payload, and then you send a bunch of other starships up, and you would refill the propellant on that starship. And once the propellant tanks are mostly full, then you can depart for Mars or the Moon, or yeah. So this is an important technology which we should hopefully demonstrate next year. So then with one of the toughest problems to solve is the reusable heat shield. So no one has ever developed a truly reusable orbital heat shield. So it's extremely difficult to do so. Even the shuttle's heat shield required several months of refurbishment, basically fixing broken tiles, testing each tile, and because it's an extremely hard problem to be able to withstand the extreme heat and pressure of reentry. And the only things that can really withstand this level of heat are advanced sort of ceramics, kind of basically glass, alumina, some types of carbon, but very, very little actually can survive the and with reusability without eroding or falling off or cracking, can survive the stresses of reentry. So this will be the first time that it's done, that a reusable orbital heat shield is developed. And it needs to be obviously extremely reliable. So this will be something that we're working on for a few years, I think, to keep honing the heat shield. It is an achievable thing. So we're not trying to do something that isn't achievable. It is within the realm of physics to get this done. Just an extraordinarily difficult thing to get done. And Mars, the Mars atmosphere is carbon dioxide, which at first may seem better, but actually it ends up being worse because when the CO2 turns into a plasma and you actually end up with more free oxygen entering on a Mars atmosphere than on an Earth atmosphere. So Earth's atmosphere is only around 20% oxygen, and Mars ends up being basically more than double that, maybe triple that, when you consider when the CO2 becomes a plasma and you get carbon and O2. So that wants to oxidize the heat shield, basically burn the heat shield. So that's why we tested very rigorously in a CO2 atmosphere, because it's got to work not just for Earth but also for Mars. And we want to use the same heat shield for Earth that we use for Mars, because there are many other factors with the heat shield, such as making sure the tiles don't crack or fall off or anything like that. So we want to have the same heat shield structure, same material on Earth as on Mars, so we can test it hundreds of times on Earth before going to Mars, and be confident that when it goes to Mars, it will work. So we're developing some next generation starships, which have a number of improvements versus our current gen. So it's taller, for example, and has a better kind of a the interstage between the ship and the booster. You can see that sort of the sort of struts there. That makes it easier for the flame like that right there. When doing hot staging, which is when we light the ship's engines while the booster's engines are still firing, the flame from the ship engines can more easily exit through the open struts of the new interstage. And in this case, we'll bring the struts interstage back with us instead of throwing it away.
Yeah.
So a little more height here, 72 meters from around 69. Propellant capacity, I think we'll probably push that up a little, maybe 3,700 tons. Long term, my guess is we're maybe around 4,000 tons. And just sort of over 8,000. I know probably like 8,300. This will keep getting up. My guess is ultimately we're 4,000 tons here, close to 10,000 tons of thrust. But this is kind of the next level, or the next version of the Super Heavy. So the booster will look a little naked on the bottom because the Raptor 3 engines don't require a heat shield. So it looks like there's kind of parts missing, but that's just because the Raptor heat shield does not. The Raptor 3 does not need a heat shield. So it's just standing there in a bathed in flaming plasma. But it's a lot lighter. Yep. Integrated hot stage. I think it looks amazing. And then the ship's a little longer, a little more capable. Moving to 1,550 tons of propellant capacity. And my guess is this probably ends up 20% more than this long term. Yeah, you can see the heat shield is sleeker, so much smoother boundaries. As the boundary of the heat shield going to the leeward side is very smooth. No more jagged tiles. I think it looks very sleek. So in this version, we still have 6 engines, but a future version will have 9. But with the Raptor 3, again, we have improved reduced mass, higher specific impulse. This is the Starship version 3 is really the version that is, I think, achieves all of the key elements. Right? Generally, with any new technology, it takes 3 major iterations of any new technology to have it really work well. And this with Raptor 3 and Starship and Booster version 3, it should be able to achieve all of the things that I just mentioned, which is a rapidly reusable, reliable rocket with orbital refilling. Basically, all of the ingredients necessary to make life multiplanetary will be achieved with version 3 of Starship, which we're aiming to launch for the first time at the end of this year. Yeah, so you can see this is kind of where things are on the left, where things will be end of this year in the middle. And as I was saying, kind of where things will be probably long term. Yeah, 142 meters. So, but the one in the middle will be fully capable of doing Mars, and thereafter it'll be a lot of performance improvements, and as has been the case with Falcon 9, we always end up making the rocket longer and increasing payload. So that's the game plan. Pretty straightforward. But it's important to emphasize, even with the rocket that we'll be launching just at the end of this year, it will be capable of making life multiplanetary, and thereafter it's just about continuing to hone the efficiency and capability of the rocket and reduce the cost per ton and reduce the cost per person to Mars. And like I said, ultimately make it so that anyone who wants to move to Mars and help build a new civilization can do so. So anyone out there, like how cool would that be? And even if you don't want to do it, maybe that you have a son or daughter